Welcome back, ladies and gentlemen, boys and girls. Today, we're going to talk about how we can calculate density. Not only how we calculate density from a mass and volume graph, but also from a formula perspective, so we can use it in a word problem situation if we're given some variables. All right, so let's make sure we have our handy dandy notebooks out. And what I'm going to want you to do is take a moment. You can even pause the video. Actually, I need to finish this right here. We are going to make our mass and volume graph where we have mass on the y-axis and we have volume on the x-axis. So we got mass in grams and volume in milliliters with two lines on them. I'll give you a moment to be able to pause the video to be able to do that so that we can talk about how to calculate the velocity from this graph right here. So pause it now. Okay, so let's get into this. So first of all, what we already know here, all right, on a mass and volume graph, we know mass is the amount of stuff within a material, the amount of matter within a material. Volume is the amount of space. A lot of people can get those two things confused. They are not the same thing. You can have something very big with very little stuff in it, and you can have something very small that has a lot of stuff or a lot of mass in that unit. The nucleus of an atom, although it's not made up of a ton of mass, it is extremely, 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 extremely small. And so all those protons and neutrons are condensed into a very small area. Another way to think of density is kind of the compactness of matter. How compact is it within that space? So we have this ratio here. So I have two lines here. I have my blue line and I have my green line. All right. My line, or we just call this line number 1 and line number 2. All right, so we can just see here already that we know that, okay, if we pick a point on here, all right, if I pick a point, let's say 12 milliliters, all right, that's a space of 12 milliliters. If they both have 12 milliliters, we can see that line number 1 has a lot more stuff or a lot more matter within that 12 milliliters than the green line or line number 2 has. Right? Which means more stuff in the same amount of space means that this blue line or this top line is going to be more dense. All right? We could talk about this from a very mathematical perspective, and we would say that this line has more slope, steepness than this line, and we know that slope is equal to our density on a mass and volume graph. Okay, so what we're going to do here is we're going to take that plus using some of our Algebra 1 skills to derive not only a formula that we can use, and then how we can calculate density given this blue line or this green line. We know this one's already more dense than this one, but now we want to know how much is it more dense, right? Is it twice as dense? Is it 3 times? Is it 4 times? Well, to know that, we need to know the slope, all right? And so let's first start this from a very math perspective, all right? We know from Algebra 1, big picture, actually we know this part from middle school, that the slope of a line is essentially rise over run. How much does the line go up versus how much does the line go over? How much does it go up and over, rise, run, rise, run? All right, that is what we think about when we think of slope, right? Is that rise over run, all right? Another way to think about it is it's a change in the y-axis, or delta y, which means change in the y-axis, divided by the change in the x-axis. All right. Now, how can we use this? This is a base formula that we can have here. All right. Now let's actually use this to what we want to do. We already said that slope is equal to density. So I can kind of plug in things that I already have on this very specific graph. This is a formula I use in math class to learn as a very generic idea. Now science is about applying some of those skills that you learn in math class. So if slope is actually density, because these are the same thing right here on this graph. Slope equals density. They are the same thing. Rise is not just some generic y-axis. We actually have something here on the rise. We have mass. And when it comes to run, we don't have just generic x-axis like we do in math class. We actually have something here. It's volume. So when we say rise over run, what we're really saying is the amount of mass over the volume. Right? And that's our formula right here. All we had to do is a simple idea of using, if we know that slope that tells us the density, I'll rise over run. The amount of rise in, or the amount of change in mass versus change in volume. Change in mass, change in volume, change in mass, change in volume. All right, now we have our formula here. We have density is equal to mass divided by volume. All right, so let's find the mass and volume of these graphs here. It's pretty easy when here because both of these lines go to 0, 0. So this becomes extremely easy. Let's do the blue line or this top line or this line number 1 first. Okay, so the easiest part about these lines is I noticed that these lines here, the slope is constant. All right, yes, the mass is increasing. Yes, the volume is increasing, but how much they're increasing is staying the same. Every time this goes up, this goes over. Every time this goes up, this goes over. And it seems to be going the same amount. How do I know? Because it's a straight line. A straight line on a graph indicates a constant slope. Or in this case, constant slope means constant density. So in this case here for this blue object, all right, no matter what point I pick, it's going to be the same amount of slope because it is because it is a straight line. So let's say I pick this line right, or this point right here. So I can pick any point on this graph. I can pick any point on this graph. The only one I can't pick, I should say, is 0, 0 because nothing has no space. So we got to pick something. All right, I'm going to pick this one right here. All right. At this point right here, I have a volume of 12, and I'm going to have to go through my words a little bit here. I have a mass of 24 grams. So to find the density, it's going to be mass divided by volume. Sorry, I should be clear. This is a capital V. A lowercase v is indicating a velocity. We're not there yet. All right. Density is going to be mass divided by volume. Right? My mass at this point, I said, is 24 grams. The volume at this point right here is 12 milliliters. All right. That's going to be 2. Okay, now here's the units. Ready? Here are our units right here. Grams per milliliter. That is our unit. We'll say, Mr. Richardson, what if I pick a different point on here? If it's a constant slope, or in this case, constant density, it should not matter. If I pick this point right here and I pick that mass divided by volume, if I cut this object in half and I'm now down to 12 milliliters, or sorry, from 12 to 6 milliliters, 6, its mass is 12. 12 divided by 6 is also equal to 2 grams per milliliter. All right, so let's look at this at the green one, or the second line here, the bottom line. All right. Density is equal to mass, little m, divided by volume, big V. I just have to pick a point. It shouldn't matter what point I pick. I'm going to pick this one right here. And it goes down to the 8, over to the 4. All right. It's the amount of mass, because mass is on the y-axis. Mass is equal to 4 grams. The volume is 8 milliliters. 4 divided by 8 is 0.8. 0.5. Here's my units. Grams per milliliter. What if I add more volume to this and put it up to 12? Well, that makes this from 12, and that puts this up to 6. 6 divided by 12 is 0.5. If it's a material, remember, every material has an ID, and that ID is based on its density. The density of an object doesn't change unless you add heat or pressure to that object. All right. So here's how we calculate. The last thing we need to add to this is our units. There are basically two standard sets of units that we use for density, and it depends on what you're measuring. All right, so we have our formula. All right, we practice using it a little bit here. We have basically two sets of units that we can use. All right, the units that we can use for this are either grams per milliliter, which we just did, all right, or grams per centimeter cubed. There are other units that you can use for density, but these are kind of the standard ones and the ones that we'll be using in a physical science setting. All right, this are the units that we would use for any liquids, because we would measure the liquid in milliliters. This one we would measure for any kind of materials that are for solids or gases. Centimeters cubed. All right. So there is how not only how we find the units, find our formula, but how to use it using a mass and volume graph. All right. Density is the compactness of particles. It's the amount of stuff in a space. All right. On a mass and volume graph, we're going to have a constant slope because that relationship doesn't change. Even if you change the shape of the material, right? If I take an ice cube and I cut it in half, yes, I've cut the volume in half, but I've also cut the mass in half. That relationship, it stays the same. That slope is called density. All right? Density stays the same, so we get a constant slope. All right? Since we know that density is the slope on a mass and volume graph, all we do is plug into that formula. Slope, which is rise over run, or in this case, density is mass divided by volume. The amount of mass divided by volume. We plug those values in. We can pick any point on the line because that constant slope should stay the same. I could pick any point on this blue line, and I would get 2 grams per milliliter because that relationship doesn't change unless I add heat or pressure. So I'm going to do my mathematics, and once I do my simple arithmetic, I get our units. No naked numbers. That's gross and disgusting. All right, never leave units naked or leave a number without units. And we either use grams per milliliter or grams per centimeters cubed, just depending on what we're using or what we're measuring. All right, I hope that explained everything. If not, don't hesitate to watch over again. I tried to highlight all the major points, but sometimes we can miss things. All right, go back. If there's a point on this board you're like, I don't understand how he got that, go back in the video, find the part where I wrote on the board. Let me talk about it one more time for you. All right. Otherwise, thanks very much for watching. Good luck, and may the science be with you.